So this is my first time at the PyData conference, and I want to thank the organizers for inviting me. So I work for the Philadelphia 76ers, and I'll show you how do we use data to change the game of basketball. So let's just get started. So imagine you're at a basketball game, and you're sitting there with your friend watching a game, and you're not looking at the scoreboard. So you're just watching the game, and you don't know what the score is. Maybe in a halftime, you are trying to guess what is the actual score of the game. Would you think you would be confident guessing the score? Who thinks they could guess it? Okay, so the point in basketball and the score is the most important and most elemental data point that happens in a basketball game. So if we cannot track the score by not actually writing it down, how can we track anything else that happens in a game? So basketball is a game where you have 5 players on each team, and a lot of actions happen simultaneously. And it's hard to keep track of all of them and everything that happens there. So let's say you're a coach and you want to adjust your strategy based on how the game is going up until a halftime. So if you don't have a data, how will you be able to adjust it objectively? You will be very biased on things you remember that happened in the game and base your adjustments on that. So for example, let's say a player scores a point out of a pick and roll action. And we have to evaluate if this point is because the player was really good and he did something amazing. Is this point because the defense was bad and the offense was maybe just average? Is the point maybe because his teammate did something else on the other side of the court that maybe we were not even paying attention to? So all these things will change how we evaluate the game, how we evaluate the players, and they're very hard to keep track of. And that's why we started adding more data to the basketball game. So we started with the scoreboard, and then I'll take you through the evolution of how we added more data into tracking basketball games. But before that, I will give you a little bit of background of where this analytics in sport really started. So it started with baseball. And the reason for that is because baseball is a more static game. And there was a lot of data that was already tracked in baseball with basic box scores. And you don't lose as much information from a box score as much as you do in a basketball game, which we'll get to that later. So these are some of the first stages of development of the analytics in baseball. So Bill James was one of the pioneers in baseball analytics, and with that, sports analytics in general. So he developed new metrics to evaluate baseball players. So this started in 1970s. Later on, Billy Bain was the GM of the Oakland A's. He started actually implementing these principles in the way he was building a team. So in the way he was bringing players to his team and evaluating how players perform. So that was in early 2000s. So you can see there was a lot of time from when Bill James started publishing these research articles until it was actually applied to evaluate players in a team. So it took 20 years to do that. And then you've probably seen the movie Moneyball. So there was a book was published. It's about Billy Bain and how he actually implemented these research metrics to build the Oakland A's team. And then in 2011, the movie version was published, and that's when it became very popular. It became well known that these things are actually being done in sports. So just to show you an example, this is what old baseball tracking looked like. So a lot of people would go to the games and they would track their own stats. And this is the reason why early on, baseball had a lot more data than other sports. And again, it's a static game, so a pitcher throws the ball. There are 11 innings, and things are very sequential. So some of the strategies started to change in baseball. So one of the examples is this one. So you can see that there's a pitcher in the middle, and he's throwing the ball to the batter on the lower edge of the diamond. And all of these players that are on the right side are defenders. So their job is to catch the ball once the batter hits it. Because they had all this data and they knew about this batter, where he normally hits the ball, they positioned all the defenders in that part of the field. You can see the left part is pretty empty. There's only one defender on that side. So they were able to do this thanks to collecting more data in the baseball game. So this has been happening in the last 15, 20 years. However, in basketball, everything started a little later, and the first person who did something more advanced, no. Okay. I will play a video because it's a really good video.
Ohio's Case Institute of Technology won only 6 out of 16 games last year. So this season, Don Knuth, student mathematician, used an electronic computer to evaluate each player's performance. Here's how he did it. During scrimmage, Knuth builds a performance record of each player, noting everything from baskets to fumbles. This data is put on punched cards and fed to an IBM computer capable of making 50,000 calculations a minute. Coach Phil Heim checks the computer's rating of each player's performance. At an actual game, he refers to the computer's findings as his strategy changes. Does the system work? Coach Heim thinks so. His team won 11 out of 14 games so far this year.
So Donald Knuth was a computer scientist who developed the system while he was studying. So this was 1958, so a very long time ago. But he hasn't done much in, or probably anything in sports analytics since then. He moved on and did some more amazing things in the field of computer science. He wrote the book, The Art of Computer Programming, which was one of the first book in computer algorithms and studying algorithms. He is also creator of TeX, the typesetting system. They all use LaTeX, and yeah, he was one of the creators. So this was 1958, and not much data was collected in that time. So in next slide. Yeah. So this is a box score from an NBA game in 1962. So you can see the data that's collected. It's pretty basic. It's the shots taken, shooting percentages, free throws, rebounds, and not even specifying if it's offensive or defensive rebounds. It was just total rebounds. Number of the assists. You can see those empty fields like steals, blocks, turnovers. They were not even tracked at that time. So you can notice this specific game is when Will Chamberlain scored 100 points. This was on March 2nd, 1962. So at that time, they were still collecting only, about 20 to 30 rows of data per game. It was very basic, very minimal processing was required to analyze this data, but there is no context provided. You don't know if certain player plays with other players. You don't know against which players he was playing at the time. And it's also purely outcome-based. So you only know the things that happen and things that they decided to count at the time. So it was very basic. And this was 4 years after Donald Knuth was helping his college team win more games. So that was 62, and then they added the assists, the turnovers, and others, and blocks. But that was all the data they collected, just the box score, until 1996 season, when they started writing down the play-by-play, which is basically a sequential list of events that happen in a game. But again, it's all the events that are that they decide to count. So you again have points, you have assists, you have fouls, rebounds. So again, very, very countable things, but it gives you a little more context. You know when certain things happen, so it preserves the temporal part of the data, and you know which players were on the court together when certain actions happened. So it gives you a little bit more context to the data. It required a little bit more processing than just reading the box score, but again, very basic, not much machine learning. So it gives you, so we went from 20 to 30 rows of data to about 300 to 400 per game. So one thing that they started tracking with play-by-play was locations of shots. So in play-by-play, you would see the location where the shot was taken. So this was like a first spatial data that was collected, was locations of shots, whether they're made or missed, and who took certain shots. So that looked something like this. So we have play-by-play and shot locations. And once we have this, some people realized that they could evaluate players a little better than it's been done so far. So up until that point, people would look at total points per game, total rebounds per game for a player or for a team, and evaluate them based on that. But then they realized players who have a lot of rebounds are also the players who play on bad teams, because their team misses a lot of shots, so they have more opportunities to get the rebound. So some of the people that started looking at these advanced stats that were called at the time, which is really just, instead of looking at totals, they were looking at percentages. So instead of looking at total rebounds in a game, they look at percentage of rebounds collected by a player while he was on the court, out of the total missed shots. So they it gives it a little more specificity on like the rebounds. The total rebounds depend on how many shots are taken, how many shots are missed. But if you want to just evaluate rebounding, this was a way to do that. So these are some of the names of the people who started developing these advanced metrics, and started developing research in basketball statistics. But it was still pretty basic. Like you can see, it's the advanced stats was looking at percentage instead of totals. And then in early 2000s, a company named SportView decided to track the players in the game. So they positioned the cameras in the arenas, which would track all the players and everything that happens during the game. So SportsView company was bought by Stats in 2008, and they decided to just focus on basketball and provide the tracking data to the NBA team. So they did a first demo in 2009 during the finals in Orlando. And the following year, 5 teams actually bought the system. So they had to install the cameras, and they had to pay for the service of receiving this data. So at the time, it was only 5 teams, and the cameras were only in 5 arenas. So these teams could only get their own data. So the data they had was really biased on how they play, because it was only their games, and they had the data of the opponents as well, but it was in their games. And then in 2013, NBA signed a contract with this company to provide the data to all of the teams. So since then, every arena has the cameras and they collect the data for every team, and every team gets the data from the opponents and from every single game in the NBA. So what is this data really? It's a spatial and temporal data. It gives us locations of players on the court in 25 frames per second. So we get the locations of the player in X and Y coordinates, and we get X, Y, and Z coordinates for the basketball. So we go from excuse me 400 rows of data to about 1 million rows of data per game. So a lot more processing is required, and machine learning techniques are required to actually analyze this data. So additionally to just the coordinates of the players, we also have the markings on when certain events happen. So we have all the dribbles, we have all the pick and rolls, we have the rebounds, all the shots, and they're marked in terms of which player took it, when did he take it. We can also see who was defending him at the time. So we have a lot more richer data and rich context that events happen in. We not only know who was on the court at the same time with this player and who was the opponent at the time, we also know how this action happened and what happened on the other side of the court. Did the action on the side matter or not? We can also try to evaluate those things now. So when this started early on, some teams took a while to adjust to actually start using this data. One of the teams that were among the first ones who were using this data extensively and developing complex models on it were the Toronto Raptors. So this article was published by Zach Lowe, and it really brought the light to what was going on and what were teams doing with this data. So this is one of the examples of the model they had. So you can see the players are the blue and white circles, and the little transparent circles are called ghost defenders. So they developed a model that would evaluate what is the best strategy for each defender at each moment, and where should he be to help his defense the most. So this was really early on, and this was really advanced. The article was published in 2013. But it didn't really go that smoothly. Like, teams didn't really adjust. The TV personnel didn't comment on it in a positive way. They would say things that it doesn't work. It's just a bunch of nerds who want to influence the basketball games. So it took a lot of time for people to start accepting this, because the coaches and the TV analysts, they were used to using their gut feel to evaluate players, to just talk about the game and make strategy adjustments. So not everybody accepted this really early on. One of the teams that was very receptive were the Houston Rockets. So this is what their shot chart looks like. So you can see that there's a lot of shots that are taken from the three-point line and around the basket, but not much in between. So if you see in this chart, the Houston Rockets took the numbers represent the percentages of shots in that region. So they took only 13% of shots between, away from the basket and the three-point line. So around this area, this whole area. And the NBA average was, this last year was 27%. You can see it's been going down in recent years. So it's not really an advanced analytics to realize that 3 is worth more than 2. But the problem was that players will make 3-point shots about 35% on average, and they'll make a 2-point shot that it's pretty far from the basket at about 42%. And it seemed like they're making them more often, so why not take them more? But in reality, the extra point you get from the three-point shot, even if you don't make it as often, is actually beneficial. And I don't think they didn't really need the player tracking cameras to realize this. So it was just a way of starting to accept the analytics and start to accept the changes in the game. You can tell a coach, hey, you should take more three-point shots and less those long two-point shots. But we couldn't see how we can get those shots and in what situations we could get them until we had all this data, so we can objectively say, hey, this is a situation where you could take the three-point shot instead of this two-point shot. So the game is starting to really change. This is one of the most popular adjustments that the game has made in recent years. So it's not just that the teams are adjusting, also players are starting to change the way that they play. So this was one of the NBA players in 2014. His shots looked something like this. So he took a lot of shots here in this long two area, and a lot around the rim and some here. So you can guess this player was like a center. He played around the basket a lot. And last year, this is the same player. 4 years later, his shot charts changed significantly. So he started taking a lot more three-point shots, even like a few steps behind the three-point line. And he really only takes the three-point shots and the shots around the basket now. So you can see the game is really, really changing. Because the offense has changed, the defense is also going to have to change. One of the examples that we can get from the data that we have now, so in the box score, we only record assists. And an assist is when you pass the ball to somebody who makes the shot. But there are a lot more things that are more responsible for making the shot than the actual pass. Like, for example, a screen assist is when a player makes a screen to free up his teammate, like this, to free up his teammate and give him a wide open layup. So we couldn't track this before. Like, we had no information about these kind of events without having the player tracking data. And as I said, as the offense is changing, the defense is also going to change as well. So this is one of the papers that was presented at the analytics conference at MIT. So they developed a system where you have the locations of the players, and from that you can infer who is defending which player. So in this example, it may look pretty obvious, but if the players are more closer together, it will become a lot more difficult. So if we know which player is defending which player, it gives us a lot more defensive information. However, there are a lot of things on the defensive end that are still very difficult to evaluate, even with this player tracking data. But we're working on the models to evaluate that. For example, there are certain things that are depending on the defensive scheme that the coach is choosing. There are certain interactions between players that are still really difficult to evaluate which player is really, really responsible for a good or a bad defense. So just another example. This is not defensive metric. This is just grouping different actions on the court. So we can find similar possessions that happen in the game of basketball and group them. So for example, if a coach calls a play and he wants to know how successful this play is, and whether he should call this play more often or whether he should try something different. So we can group certain actions together and find when did the coach call this play in every game. And we can also find other teams that use the similar kind of play in their game. And we can evaluate how successful is this play against certain defenders, maybe against certain teams, and which players are more successful using this kind of play compared to maybe some other players. So we have a lot more data now that we can evaluate, that we can use to evaluate teams and basketball players. So so we can use it to form a strategy for the game. We can use it to form a lineup that we should play in a game. We can see certain players play well against certain opponents, so maybe we'll try to match the lineup of the players against the opponents they play well against. Also, when we are signing a player, when we are looking to trade a player and trade for a different player, we can use all this data to evaluate the players better than we could before. But there's still some things that are missing from the data, and that's primarily the things that don't happen. We don't know if a player was looking in a certain direction and decided to not do certain event, but certain action and do something else. So there's still a lot more work that we can do. But I would say we've come a long way in last 5 years, really, since we had this data. And the game is really adapting to it, and the game is really changing with all this new data. So a little early, but I'm happy to take any questions you have, and thank you for your attention.
Bueno, ¿alguna pregunta?
Hi. Do you run models in-game to make adjustments? I don't know if you tell the coaches something about you find, and what kind of models you run if you do it during the game.
Yeah, so during the game, if we have all this data previous to this game, during the game you only have like small amount of data added to the old data that we already have. So it would probably not change how we think about the game based on that small amount of data. We probably wouldn't want to react to a small sample size that happens during a game. There are certain adjustments that we can make just by seeing things that happen, seeing which player was better by looking at the at really the box score and play-by-play data during the games. But the player tracking data, we don't use it during the games. We actually don't get the game data until maybe an hour after the game ends. So it takes a bit of time to process it and to actually make decisions on it.
Okay, thanks.
Yes.
Hi, thank you for your presentation. I have somewhat related question. Are there plans for adding some extra data, some extra sensors, maybe something additional?
It's a little difficult due to the rules in the NBA. We can't really have sensors on players during the game. So we can't really get the data from sensors. What we could do is look at the video and maybe analyze it a little more. Like we could use like pose data and see the player's arms location maybe, and their feet location and how they're positioned in the defense. So right now we only have coordinates X and Y. We don't know which direction player is facing, for example. Let's say he's playing the defense, and we don't know if he put his shot up to contest the shot, put his arm up to contest the shot. So this would all be like very useful data to have. But right now we only have the coordinates.
Thank you.
Thank you. I find it really fascinating what you do with data, so thank you very much. My question is, when you're processing all of this, you probably find yourself in front of thousands of rows of data. Can you share some insight of how you decide which data is useful and can be actionable and which data is just random?
Mm-hmm. It's a really good question. So a lot of it depends on the maybe time of the year, which game we're going to play soon, whether we are developing some long-term projects. Then we can do some more research-oriented things. During the season, we'll focus more on how our team is performing, evaluate our players in certain actions, how they are playing, which lineups are playing together well, and we'll focus also on the opponents and try to see what are the opponents' strengths and weaknesses that we could use to play better in the game. Yes.
Hi. I have two questions actually. One is there any particular point of data that you have noticed that it was like, I wasn't expecting that in the, like, is it something on the data that was surprising for you?
I'm not sure of a specific example, but it happens a lot when you watch the game and then I would see something and be like, hey, maybe I should check that. So then I'll check it later and see if it really confirms what I'm like seeing in a game. Sometimes maybe I just see it a few times in recent in like a recent game, and then I'll think that this happens often, but then I'll check the data and see that, oh, this actually does not happen that much. So maybe things like that.
Okay, and the other one, you mentioned that one of the interesting points will be to have a register of what the player is actually doing, like where it's watching and what's trying to do. Is there any other thing that you would like to track on games?
Well, besides the player's arms location, where he's facing, I think that would give us a lot more complete picture. I think also whether the player jumped or not. Because we have, for the basketball, we have the height of the ball, but for players, we don't have whether he's jumping, how far he's jumping, and maybe how close is he coming to blocking a shot. So we can't really see that data. We can see how much he affects the shot by how often players make the shot against him. But having a little more specifics on how players playing in a defensive part of the game would probably be very helpful.
Hi. First of all, the presentation was amazing, and just the fact that you are doing this in something that some people can say it's completely out of the it's completely different in areas. It's really amazing. I really love the idea of the whole that speech in the book of that was based on Moneyball because of this, that you use data to improve the game. So that's really amazing. My question was regarding you say, well, for example, you don't really have the information like where is the player facing when he's doing a shot or when he's receiving a pass or something. And you said something about watching the videos after. Have you, or is it in thoughts of doing some probably computer vision pipeline that does this automatically and adds that into the data set?
Yes, there's a package called OpenPose, and it can actually detect people in general and their body parts and their like arms, legs, and where they are facing and where they hold their arms. So there we could look into extracting this information from the video, but then we only have like a broadcast video. So sometimes a player is on outside of the screen of the broadcast. A lot of times the broadcast is facing on a coach or something, and while the play is still happening, so you would lose a lot of information. Some of it could be, I guess, inferred based on where the players are and how they're moving, but it's a very complex problem.
And regarding that, how, probably this is more personal, but how do you feel that not the team, the 66ers are reacting to the ideas that you pitch of using the data? They are really supportive of this, or have you faced really difficult walls, so to speak, to say no, you really can't do that?
So I think we are very lucky at the Sixers. our organization is very receptive of the data, and our our owners come from a financial field, so they're used to looking at the data, making decisions based on data, and they invested a lot into our data team, our research team. So we have 10 people in our research team, which is the most of all the NBA teams, and our coaches are also very receptive of the data insights. They like to they like to make decisions that are based on the objective data. So they'll come to us with questions and ask us which things are more effective, which defense type is better against certain players, and things like that. So they're very receptive of the data analysis.
Thank you.
Thank you.
Hi, Ivana.
Hi.
Very interesting talk. Thank you. So my question is basically, it's actually a follow-up question. So after you get the data, so you said there are like 25 frames per second. So and then and once we get those images, then we need to find out if in those images there was a dribble, if it was a pass. So this labeling of images, it happens. So you get labeled data, or after you get those images, you have to label data on your side.
So that the data that we get is already processed from the video. So we actually get the coordinates of the players already processed from the cameras that are in the arena, and we also get markings on top of that. So the shots, passes, it's all already provided by the company.
Thank you.
Here. First of all, thank you for your talk. It was really interesting. My question is regarding to the tracking during the matches. You mentioned you don't get the results until 1 hour after the matches. So does that video processing involves any manual steps? It's all done through computer vision, or is some human interaction there for tagging what's happened on the matches? Thank you.
Well, the company that provides us the data, they already give us process data. Previously, in last 2 years, they haven't been doing any human tagging. Previously, sometimes there was a person standing next to a computer, and a window would pop up and ask, "Hey, is this player?" Just to confirm which player that is, because sometimes maybe the number of on the player's jersey was not readable, so it required a little bit of tagging. But right now, it's all automatically processed.
Última pregunta.
Hi, I love your talk. I didn't know about Knuth in basketball.
Thank you.
And a question that I would like to do it is that do you know about some methods or models that you are developing in sport analytics that are being applied in another field, like business or defense or something like that?
I would say a lot of the methods that we use, like from machine learning, from maybe clustering, maybe regression, are pretty similar to what's used in other fields. So I think the methods apply to basketball. It's just like the way we interpret it. It's gonna change a bit based on context.
Hi, thank you for the talk. Two short questions. One, how open is the world of basketball analytics? Do the breakthroughs get published, or are they kept secret as a tool to take an advantage over the other teams? And if you can share that, which tools are you using from the data science ecosystems that we can know?
So because the way basketball is and the way NBA is, it's a very competitive business. Whoever wins the most games is gonna have the most revenue. Well, mostly. So we are very actually secretive about how we evaluate players, how we evaluate teams. If you think about it, the reason to do that is, let's say we want to trade with another team, and we have certain model about a player, and we value this player maybe more than the other team does. So the other team will easily let go of this player, and we won't have to give them as much as we value this player, for example. So I think there's a lot of competitiveness there, and we wouldn't want to other teams to know how we evaluate players, because then they would know how much we value them, and they could ask for a higher price. From the technology standpoint, we are developing our own codes and processing and models in-house. So mostly we just write everything in Python. We have our database on the Amazon services. And yeah, so most of the things we do in Python.